Welcome back, everyone. Here is Mrs. Faune once again. In this particular lesson, we will be needing our Desmos calculator. So I hope you have it available and open. So what are we going to do today? So today we will calculate the maturity of an account using the change of base formula. So we will be calculating the approximate time for your money to grow to your desired amount given certain interest rate. So we will be using both the compound interest formula. Let me just rewrite it here so that everybody could see it. A is equal to P times 1 plus r over n raised to n t. So where A is the desired amount, P is the initial amount. Sometimes we call it principal. So this is how much money we're putting into the account. That's your P. R is the rate. Look for the number that has a percent symbol. And this is always expressed as decimal. So another term for this is principal. And this is always expressed as decimal. So how do you change that to decimal? By dividing it by 100. Divide the number by 100. Okay. So the meaning of percent is for every 100. So always divide that by 100. While n is the number of times compounded in a year. So see the table. Here is our table. How it is compounded. So if it is compounded annually, the n value is 1. That's the n. If it is compounded semi-annually, the n is equal to 2. So these are the n values. I will put here n equals 1, n equals 2. Quarterly, n is equal to 4, meaning it will be compounded 4 times a year. So every 3 months. 12 divided by 4 is 3. So it will be computed every 3 months. Monthly is 12 because there are 12 months in a year. Weekly is 52, and then daily is 365. During leap year, there is an additional 1 year. So this will become 366. Okay. Now, what about the change of base formula? So remember, the logarithm of b to the base a, we rewrite this as the logarithm of b divided by the logarithm of a. So using the change of base formula. So the logarithm of b to the base a, you divide the logarithm of b and the logarithm of a. That's why you need your Desmos calculator. Okay, let us begin with our first problem. So let me remove this first. Our first problem is here. So Nancy and Bob want to renovate their kitchen sometime in the future. They have deposited 16,000 into an account. Let me highlight the word deposit, 16,000 into an account that compounds interest monthly. So how it is compounded? It is compounded monthly at a rate of 2.4%. How long will it take until the account reaches 20,000? So there. So the word how long is how many years will it take until the account reaches 20,000. So this is our T. This is our goal. We have to find T. So what are the steps in solving word problems? First, I kept on telling you this. We should be able to identify the given values, know the data, know the numbers. So first, what is 16,000? Says here, they deposited 16,000. So meaning to say, this is the initial amount. So $16,000. And they want it to reach 20,000. Okay? 20,000 is the desired amount. Okay, so 20,000. And then the rate is 2.4%. You must express this to decimal. How? By moving two places to the left or divide this by 100, because percent means for every 100. And this will equal to 0.024. And then the n, how it will be compounded? It will be compounded monthly. And monthly n is equal to 12. Their n is equal to 12. So I'm going to write here 12. There we have identified our given. Then we're going to replace. We're going to plug in these numbers to that equation. That is step number 2. Substitute the given values to the formula. Our A is 16,000. So we have here A will be 16,000. Sorry, it's not 20,000. Sorry. So this is 20. A is 20,000. Our P is 16,000 times 1 plus R. The R is 0.024 divided by N. The N is 12. So raised to N, which is 12 times T. So this is what we are looking for. We're looking for the T here. There. Okay. So let us recall what we have done last week. So first, we must write this in standard form. What is the standard form? Standard exponential form is A equals B raised to X. So in order to do that, what shall we do? We must divide both sides by 16,000. Okay, 16,000. So 20,000 divided by 16,000 is 1.25. 16 divided by 16 is 1. So we just have 1, and or just simply cancel that. 1 plus, so divide these two as well. So let us use our decimals and divide the decimal. So 0.024 divided by 12, we have there 0.002 raised to 12t. And now, using PEMDAS, let's add this first. So we have 1.25, 1 plus 0.002 is 1.002 raised to 12t. And this is now our A, this is our B, that's the X. We have written it in that format. Next, the next step is write a logarithmic equation. So going back, let us recall, how do we transform or express A equals B to the X in exponential form? So remember, we can transform this as the logarithm of, we have here A to the base B is equal to X. Okay, the logarithm of A, that's the base, and that's the exponent. So we follow the same thing here. So we will rewrite this as, okay, what is our base? The base is 1.002, and then that's the answer. And then instead of writing the equal there, I can write my equal here. There's no difference. It's the same thing. Remember, we can rewrite this as x equals the logarithm of a to the base b. It's the same. So a equals b is the same as b equals a. So it doesn't change. Okay. Now, how do we solve this? Our goal is to find our t. The t is there, but there's a 2 here. So let us connect this to our simple algebra or simple math. If I have here 5t is equal to 25, how do we solve for t? So to solve for t, we must divide both sides by 5. So 5 divided by 5 is 1. 1t equals 5. Okay, so there. We do the same thing here. To get rid of the 2, we must divide both sides by 2. Okay, both sides. Because if you divide only one side by 2, this will not equal to the original equation. The value will change. So it must be both sides to keep them balanced, to keep the values the same. So 2 divided by 2 is 1. 1t, and then we just copy the entire thing, equals the logarithm of base 1.002 to 1.25, or the logarithm of 1.25 to the base 2 divided by 12. Sorry, this is 12. Okay, divided by 12. So that is 12. I'm sorry. So divided by 12. So 12t. So 12t there. Now here, if we look at this, and if I'm gonna cover this one, we use the change of base formula. So change of base formula will be, okay, here, I'll just copy the denominator. I'm not gonna touch that one. Writing that in the change of base formula, we have here the logarithm of 1.25 divided by the logarithm of 1.002. So the logarithm of 1.25 divided by the logarithm of 1.002. So let us use our Desmos calculator to find the answer to that. Okay, so here, let's go. There is the fraction. And let us enter the log, go to function, press the log, and then go back to the main. 1.25, okay, let's close that, divided by, go back to function again, check the log, enter the number. So 1.002. We close that. There we have it. 111 point, let us round it to 2 decimal places only. So, and then divided by 12. Okay, what will be our t? So what is our t? We have 111.68 divided by 12 equals 9.3. Okay, the answer is 9.3. So there, what does it mean? It means that it will take approximately 9.3 years for 16,000 to grow into 20,000. So in this savings account. Okay? So it will take approximately 9.3 years for 16,000 to grow into 20,000 in this savings. So this is problem number 1. See how we use these two formulas, the compound interest and the change of base. Okay, let's have one more problem. So there. Let me change this one. And here is my second problem. So Jasmine wants to start saving to purchase an apartment. Her goal is to save 225,000. This is her goal, to save 225,000. So meaning to say, this is our A, 225,000. If she deposits, so she deposited 180,000. So meaning to say that's the initial amount, or that is the money she put or she deposited. So this will be your P, 180,000. And it pays an interest rate of 3.12%. And it will be compounded monthly. So again, monthly is 12. So monthly is 12. So I'm going to show you again here. Monthly N equals 12. Okay? And then the rate is 3.12%. How to express in decimal? You have to divide by 100. That's the meaning of the percent symbol there, 3.12%. Or you can just move these two places to the left, just like what you were doing in the middle school. So when you divide or when you move, this will gonna be 0.0312. And now, next is we're going to put all these numbers in the equation, or in short, we substitute these values to the formula. Starting from our A, which is 225,000 equals P. Our P is 180,000. Parentheses, it means times. 1 plus the R is 0, or 0.0312 over the N is 12. And our exponent is NT. N times T, meaning to say the N is 12 times the time. And we are looking for that T again. So, just like what we did in our first problem, we must rewrite this first in standard exponential form. What is the standard exponential form? We must write this in this format. A equals B to the x power. So, why do we need to divide this by 180,000? Because in our standard, the coefficient of B is 1. So we have to change this into 1. In order to do that, we have to divide this by 180,000. Because 180,000 divided by 180,000 is 1. And to keep it balanced, whatever we did here, we must also do it on the other side, or else the value of the equation will change. So this is 180,000 as well. And 225,000 divided by 180,000. So we will get 1.25. So this is 125. 180,000 divided by 180,000, that is cancelled. This is equal to 1, or we just cancel that 1. And so we just drop that. We will get 1 plus 0.0312 divided by 12, then raised to 12t. Now let us combine this. 1.25, 1 plus. Okay. We will divide. Let us use our Desmos again. And let us divide this one. So 0.0312. So this is, I am showing the Desmos because there are some of you who emailed me and want to know how to use the Desmos. Okay. Divided by 12. So this fraction is equivalent to 0.0026. Raise it to the power of 12t. And then we will add first, remember the PEMDAS, 1.25, 1 plus 0, zero point 0 is going to be 1.0026, and then raised to 12t. And once again, we were able to write this in the format a equals b to the x. There. Next, what do we do next? So here is our a, and here is our b to the x power. Now, we are going to rewrite this in logarithmic form, or we will write a logarithmic equation. So once again, in order to do that, we can write this as x equals the logarithm of a to the base b. So we do the same thing here. My 12t equals the logarithm of 1.0026, or the logarithm of base 1.0026. The base is the subscript, and the answer will go there. How do we read this one? The logarithm of 1.25 to the base 1.0026 equals 12t. And to solve for t, we have to get rid of the 12. So we must divide both sides by 12. Divide that by 12. 12 divided by 12 is 1. So we have 1t equals. So we just copy this. Bring down the logarithm of this base 1.0026 and 1.25 over 12. So we can rewrite, remember the change of base formula. If I have that, change of base is logarithm of a over the logarithm of b. So what is my t here? I'm not gonna, okay, we have here the logarithm of 1.25 divided by the logarithm of 1.0026 divided by 12. That's the top. Okay, we're gonna do that first. So what would be our t? Once again, let us enter this in our Desmos calculator. So we have here, this is over 12. Okay, that's over 12. So let us enter that. There is my arrow. I'm gonna go to function. Then we're gonna enter the log first. The logarithm of 1.25. 1.25. Oh, sorry, let's do the fraction first. Okay, let me clear that. Hit the fraction. So we have the logarithm of 1.25 divided by the logarithm of, okay, 1.0026 there is equivalent to, let us estimate this again, round up to the nearest 100. So we have here 85.94. So there. And now we have our t. So let us divide that. 85.94 divided by 12 is 7.2. Okay, 7.2. It says here, round your answer to the nearest tenth of a year. So nearest tenth. So only one decimal. So 7.2 years. Okay, once again, how do we interpret the 7.2? It means that it will take approximately 7.2 years for 180,000, okay? So to grow to 225,000.